Hello.
Hello, I'm
Hello.
sharing.
Okay.
We work in Campinas University, and we have made some pedagogical experience thinking in a student who will use the computer to make any calculation. How we must change the way of teaching for these students. One of the ideas is that we should prepare a student to cooperate with machines and do not act as a machine, do not substitute a machine. Then in ordinary differential equations, qualitative view, the using vector fields and analogy with partial differential equations, is an empowerment for this student. Instead of follow the article we have written, I, Daniela, and Rafael Pdes, who are students of mine in the masters, looking for these new strategies of education. I will follow a Wolfram Cloud notebook, working in a problem which students can find in their first years. I will act as a student who is reading Edwards and Penny, a common book of calculus, and wants to employ the
Excuse me, Professor
software.
Rosa. Sorry for interrupting. I don't see a presentation. Do you mean it, or you have presentation and you couldn't share it? I see just the paper, not the presentation.
For a while was the paper, I was speaking. Now I will begin with the presentation. I
Yeah.
was explaining that I will act as a student that wants to solve a problem of Edwards
Okay.
and Penny in Mathematica from Wolfram. Let's see the Wolfram cloud. Can you
Okay, that's
see
great.
that? Can you see that, sir?
Yeah, sure, sure. We see it. Yes, that's right.
Good. It's a problem linked to alligators. Then you do have this differential equation here. That is given by the authors, Edwards and Penny, and they want to know the time evolution of a population of alligators with two different initial conditions, x equal to 25 or x equal to 150 when t is equal to 0. Then the first approach, if the student wants to simplify too much, he goes to the Wolfram soft and type the differential equation and use the DSolve command. Let's see what happens. Well, if you see the solution, the expression the soft gave will approach 0 when the time is very big because of the exponential. But this is not a right answer. It's not a complete answer. And it not understands what's happening with the population. The softs, they do have many pit fails. In the paper, we show other pit fails. I'm showing only a simple one to introduce the ideas of the paper. Well, instead of simply employ the DSolve command, he could to analyze the equilibrium points of the equation, the solutions which are constant. And if you give a look, you can have x equal to 0 and x equal to 100. Then these two solutions, they divide the theater of solutions because of the existence and unicity theorem in two qualitative solutions, the cases in which the initial conditions are bigger than 100 and smaller than 100. If he returns to the differential equation that was this here above, and thinks as a declaration of the slope of the solution in function of t and x, that in this case, that is a autonomous system, depends on x. He can give a look in this slope, that's the right side of the differential equation. If he defines the function slope and table, he sees that the solutions have negative slope for x small than 100 and positive slope for solutions bigger than 100. Then he can see that if the initial condition is bigger than 100, the population will increase because the slope will be always positive. But if it's smaller, it will decrease. Then he can see that this solution is not complete. It's avoiding the solutions in which the population increase, because this solution given by the simple command would give solutions going to 0. And we would leave 1/2 of the one kind of solutions out. Because of the numbers here in this table, the student can see that the computer won't show him many things because the slopes are very small. This can be changed. We can change the time unity. Take 100, this one, then the new slope function is this, and then the slopes are more suitable to plot. There is no problem to change the time unity, and now he can plot using the vector field command. These slopes, they will be better. Let's prepare a second theater, putting the initial conditions that are 25 and 150. And let's after use the vector plot with this vector field. The vector field has to have the slope given by m2. That's the function that appears in the right side of the differential equation when you change the variable to tau. Then you can define a vector field such that the second component divided by the first is exactly to m2. If we do that, and we ask for the soft, we ask to the soft to draw the slopes. We have the slopes. You see that the variable changing I have done is very nice, because now you see that solutions big in which the initial condition is bigger than 150 will explode. And if the alligators are only a few alligators more than 100, they will disappear. If the alligators are more than 150, they will increase indefinitely. Historically, in Australia, everybody knows about the rabbits. In Brazil, the meat production has to do with this. The Indian cows were brought to the south of Brazil, and we had an explosion. This would be some kind of critical mass. If you have less than it, the population disappears. If you have more than it, the population increases and increases. Let's see together with the two constant solutions and the initial condition. Then the student at this moment, he would employ his human abilities, visual and artistic abilities, to have a qualitative view of what's happening. And then he can turn to the computer and say, oh, that solution that the DSolve had given me was not nice. It was not nice. Why? Well, he could try to solve the differential equation by integration using the soft. That means it's a separable equation. And then as he tries to do this, to avoid the DSolve, to try to understand it, he can integrate the right side, no? the X side, and he has this. And here we see the failure of the soft, because when the soft writes 100 minus X inside of the log, he's forgetting of the modulus. And when he forgets the modulus, he is putting out the solutions in which X is bigger than 100. No? Let's make the partial fractions expansion that probably the computer has used. Then he integrated here, or in such a way he found this expression that he's forgetting the modulus. He didn't put the integration constant, but that's okay. The modulus is much worse, because then the solutions in which X is bigger than 100 will not appear. Everybody knows that the log modulus is much better primitive for the inverse, because it fits the two sides of the inverse. While if you use only the log, you will find on the right side. In this case, in which we have log of 100 minus X, there is a qualitative effect, because solutions in which 100 X is bigger than 100 will give an explosion of the population. And the solutions in which you have less than 100, the population of alligators, poor alligators, will disappear. Then he has to correct the soft. If he corrects the soft exponentiate, he can write the set of solution as the level set of this function. And the softs are very good to draw level sets. Then if he characterizes the solutions as level sets of these functions to the right, he can use the contour plot to plot them. And the softs work much better with the contour plots that are based on level set idea.
Still 1 more minute, Professor Rosa. 1 more minute.
Yes.
Okay. Just a minute. Just still 1 more minute.
Yes. Okay. Then he can define the function and get the two special values of the constant for which he defines the function, and get the two values of the constant for which the book asks, that is 25 and 150, and plot together this particular solution in the theater. Then he gets the perfect solution of the problem. In our article, we point to this kind of situations in which the soft does not solve or give very complicated solutions. And the student sometimes has to write a partial differential equation linked to the ordinary differential equation. Then the soft solves it because he accepts implicit solutions for partial differential equation. And use a lot the graphical facilities of the computer to make a geometrical interpretation. And then he turns to the commands, but knowing what's going to happen. And with this knowledge, he can avoid pitfalls and some confusions that are natural. For instance, this case here, in which we find the solution with the computer, not with the DSolve, but in a bit more sophisticated way, then this solution gives two level sets for each value. You can see by plotting, and then you can separate the solutions you need. And then what the paper claims is that in these times we are in which students will work with softwares, we do not have to prepare human beings to substitute machines, but to cooperate with machines. And to cooperate with machines is much easier if you use your visual abilities, if you use the soft to produce graphic draws, and then the qualitative and geometric point of view is much more important than before in the courses, and should be given in the very beginning, and linking differential equation, partial differential equations, and vector fields. That's the claim in the paper, and this is a result of our experience teaching at Unicamp, Campinas, for students of engineering in their first years.
Yeah, Dr.
Okay.
Rosa, we need to stop at a specific point to have some questions. So,
sorry?
Do you want to start
Yeah.
having questions now, if there is any question? Or you still want to present something?
Sorry?
You still want to present something more, or we can start having questions?
No, there is this other question here.
Okay.
I do have more time.
No, the time finished.
Then I may, you can make questions if you want. I can explain some idea you want.
Okay, if there is any questions, guys, if there is any question, go ahead. Any questions?
Another equation?
No questions.
This equation, for instance.
May I?
No, Dr. Rosa, questions, guys, questions. If anybody want to ask.
May I? It is
Yes.
it is clearly seen. It is mathematical problem. I am from the area automation. I am not from mathematician. That's why that means I see clearly that by your solutions you have some feedback, and by the initial point more as 100, you have a positive feedback. You have practically generator. And if you have initial point less as a 100, then you have a negative feedback. I mean only my remark from the point of view of automation. But as for the presentation, it was very interesting. Thank you.
Okay. You see, there are other problems too. Sometimes the DSolve gives you a solution, but it's very complicated. Because the computer, this is something the Wolfram will put in order, they will fit this, but the software does not give you implicit solutions. He wants to isolate X. Then sometimes it's much easier to solve the differential equation. You write analogous partial differential equation with the idea that you have slope fields given by this function, and construct a partial differential equation in which you look for a solution for which the level sets have the same inclination given by the slope field. Then if you apply the DSolve to the partial differential equation, it works. Because then it accepts implicit solution, because in the partial differential equation, X and Y are in the same fit, and you can use it. But you be secure to give solutions, practical solutions, only if you make the graphic analysis. And for this, the soft is very good. Because sometimes you find a function for which the level sets like this give more than one solution, and then the graphic analysis that will say to you that you can give a small change. In this case, is a population that has a linear and a stable value. And then you have three kinds of solutions.
Okay, thank you.
Okay, thank you so much, Professor Rosa.